Okay, let's talk about a challenge that pretty much every university student has faced. You know the one, that big, intimidating assignment that just lands in your lap. Well, today, we're diving into one for discrete mathematics. And, this one's got a fun little twist.
Ah, yes, the classic deadline threat. You can almost feel the clock ticking, can't you? It's that familiar pressure, that race against time that we all know so well.
And that's the big question, isn't it? You're just staring at this stack of paper filled with problems and symbols and rules, and you're just thinking, how do I even start? Well, that's exactly what we're going to unpack right now.
So here's our game plan. First, we'll look at the challenge itself. Then, we'll get familiar with our toolkit, in this case, MATLAB. After that, the fun part, turning those weird math symbols into actual code. We'll even visualize a solution. And then finally, we'll talk about what this all really means way beyond this one assignment.
All right, let's dive into section 1, the assignment challenge. First things first, we've got to understand exactly what's being asked of us. So the instructions are pretty standard stuff, right? Do all the questions, work in a group. But then you get to the really important part. Use MATLAB. And not just use it, but show your commands and the output. See, it's not just about getting the right answer. It's about proving how you got it in the language they want. And that brings us to section 2, your MATLAB toolkit. That little instruction about using MATLAB, well, it's not a hurdle. It's actually a massive hint. It's the secret weapon.
You've got to let this sink in. This is so crucial. The professors aren't trying to make your life miserable. They're actually pointing you directly to the best, most efficient tool for the job. And once you wrap your head around that, everything changes.
So what is MATLAB, really? Well, for our purposes, think of it as your personal translator. It takes all those abstract, kind of scary-looking math symbols and turns them into simple, almost English-like commands that your computer can solve in the blink of an eye. Okay, section 3. This is where the magic really happens. We're going from symbols to code. Let's see just how easy this translation can be. Let's take a look at question 1. It asks for the union of two sets, A and B. In math class, you write that U symbol. In MATLAB, you literally just type union of A, B. That's it. It's practically telling it what to do. And it's the exact same story for intersection. That upside-down U symbol, it just becomes the word intersect A, B. You don't have to write some complicated loop or logic. You just ask for the intersection. And for set difference, finding what's in A but not in B, you've probably guessed it by now. The symbol becomes the command setdiff A, B. You see the pattern here, right? It's a direct one-to-one translation from math language to computer language. Okay, that's fine for simple sets. But what about the really hairy stuff? Like, remember question 7? It's asking for the row-reduced echelon form of a matrix. I mean, that sounds way more complicated. And this is where you really see the power. Something that would take you like a whole page of careful manual calculations by hand is reduced to one single command, RRF of A. You just define your matrix, you type that one little command, and bam, the answer is right there. It's done. All right, let's tackle another area. Question 5 is all about analyzing relations, determining if they're reflexive, symmetric, or transitive. And these problems can be real head-scratchers because they're all about definitions and logic. So here's the key. Instead of just staring at these sets of numbers, trying to remember the exact rules, you can actually write simple logical tests in MATLAB. You can program it to check for you, hey, is this thing reflexive? Is it symmetric? And get a clear yes or no. Then you can just present your results in a nice, clean table like this. Now we get to my favorite part, because sometimes the problem isn't about numbers or logic. It's about seeing the shape of the answer. Let's jump to question 8. So this question wants us to sketch a piecewise function. All it really means is that it's a function that plays by different rules for different parts of the graph. When x is less than -1, it does one thing. When x is between -1 and 1, it does something totally different. Now, trying to draw this accurately by hand, It can be a real pain. But in MATLAB, it's just this beautiful logical process. You just tell it the rules for each section. You define the x values and what the y values should be for those sections. And then you just use the plot command.
And just like that, all that abstract text on the assignment page is transformed into one simple, clear, perfect image. This is what MATLAB does best. It takes complexity and makes it visible. It makes it make sense.
Which brings us to our final section, beyond the assignment. Because after all this, after solving all the problems, what's the real takeaway here?
You learned a method. You learned how to look at a huge, overwhelming challenge and break it down into smaller, solvable pieces. You learned how to find the right tool for the job. And maybe most importantly, you learned how to translate an abstract idea into concrete logical steps. And that skill, that goes way, way beyond just this one class.
And that's really it. This whole assignment wasn't just about math. It was a training exercise in a modern way of thinking, of problem solving. So the question I want to leave you with is this. What other problems in your world, in your life, could you solve if you just found the right way to translate them into code?